All right, now what I would like for you to do is I would like for you to think of the equal sign being the center of the equation, right? You got a left side, you got a right side that way. You're always going to find the side that the x is on. In this case, the x is on the left, so that's where you're going to start doing your work, okay? That's where you're always going to find what you're going to do the opposite of. You're always going to do add or subtract first, and then you're going to do multiply or divide. All right, so on this side of the equation, it says minus 4, right? So opposite of minus 4 is plus 4, okay? So we're going to do plus 4 on that left-hand side of the equal sign, and then cross the equal sign and do a plus 4 again. All right, now which set of those numbers get crossed out? The negative 6 and the 4, or the negative 4 plus 4? Yeah, negative 4 plus 4, because that equals what number? 0. So we cross them out on add and subtract because they equal to 0. All right, now something that we didn't see on Wednesday. On Wednesday, we just had an x down here. But now, instead of having an x left, we have a negative 2x left over. And then equals, now what do we get when we take negative 6 plus 4? Negative 2. Okay, now this should look like the one-step equations we did on Wednesday. This is a negative 2 times x, right? A number and a letter squished together means times. I want to do the inverse operation, so I'm going to divide by. Now, what number am I going to divide by? A negative 2. Okay, we're going to divide by the exact same number that is sitting in front. Okay, now on this left-hand side, we generally cross them out, right? Because negative 2 over negative 2 equals 1. All right, when we are adding and subtracting, we cross them out. We cross them out because they equal 0. But when we're dividing, we cross them out because they equal 1. Now, we have the exact same thing over here, negative 2 divided by negative 2. But do I want to cross them out over here? I don't want to cross them out because I need an answer over there, right? So negative 2 divided by negative 2 is a 1. So this one turned out to be just an x equals 1. Okay, so show of hands. Did we do that last year? Did we do those type of equations last year? And we're saying, yeah, at least the vast majority of you are. Okay, now we're going to do another type. Does x always have to be on the left? Nope, I can put x on the right if I want. All right, so let's do maybe say 5 is equal to an x over a 4 minus 10. All right, think of that equal sign being the center of the equation. So I have a left side and I got a right side. Which side is the x on? Yep, the right. Okay, so then that means I'm going to work with these numbers over here to get rid of them. All right, I always do add or subtract first, then I do my multiply or divide. What number is being added or subtracted? Yeah, minus 10, right? So the opposite of minus 10 is plus 10. So I'm going to put the plus 10 right underneath there. Then I'm going to cross the equal sign and put it over underneath the 5. So plus 10 over here. All right, which set of numbers gets crossed out? The 5 and the 10 or the 10s? The 10s. Okay, because a negative 10 plus 10 falls out. All right, I'm going to go ahead and add 5 and 10 is just 15 is equal to, now everything that's left right here is going to come straight down, so I'm going to have an x over a 4. Now that looks like the ones we did on Wednesday, one-step equation. What operation do you see right there in the equation? You see x over 4, which means x divided by 4. This means x divided by 4. What's the opposite of dividing by 4? Multiplication. Okay, so we're going to put, this is where I do the times 4, and then I kind of put this one, remember, up high a little bit, so I realize that that 4 is in the top and this 4 is in the bottom. All right, and then that lets me cross those out. Again, they cross out because they equal 1 for the same reason over here. One's on top, one's on the bottom. If I do a times 4 on that right-hand side, I've got to do a times 4 on the left-hand side. Okay, and then some of you can multiply 15 times 4 in your head. Others of you might need to use a calculator. A couple of you said 60. Yep. All right, and it's okay to have like 60 equals x. I can keep that x on that right-hand side. It doesn't make any difference. All right, now, show of hands. Did we do that kind last year? Okay, we should have, right? Okay, now, here's the kind. You know how to distribute. Okay, we distributed property, what's on the outside of the set of parentheses, and then you multiply both of them. So we could also do problems that maybe, say, had a 2 parentheses 3x minus 5 equals 10. Now, this is really technically more than a two-step equation, but it doesn't look like this. It doesn't look like this. It's got a set of parentheses. All right, now, from what we've already done, distributive property, do I know I'm supposed to take the 2 times the 3x and the 2 times the 5, right? So that's kind of like an extra step before you start this. You're going to distribute the 2. If it has a set of parentheses, you're going to distribute the 2 first. All right, 2 times 3x, 2 times 3 is, yep, 6x, so I'm going to write down 6x. 2 times the negative 5 is negative 10, so I'm going to go minus 10, and then I've got equals 10. Now, after you distribute, it looks just like this one, because a number in front of the letter, and then plus or minus, could have been a plus, but it was a minus, all right, equals 10. So it now becomes this two-step equation. All right, so I'm going to give you just a minute, finish that one on your own, all right, and we'll see if you can get it right. And then when you get down, you may get to a stopping point and then get lost. So if that's the case, you can go ahead and just stop, and we'll talk about it here in a minute. I'll wait another minute or two. Excuse me. All right, so first thing you did was what? Arlie, what's the first thing you did? Yep, added 10. Add 10 to both sides, right? Okay, so we added 10 to both sides, crossed out those 10s on the left. Then I brought down the 6x. 10 and 10 give me a 20 here. All right, then we should divide, right? Divide both sides by 6. All right, but then you might have panicked because 20 doesn't divide by 6, right? I mean, you're going to get a decimal, okay? It does not always have to be an integer or a positive number. I don't want you to grab a calculator. All right, what I want you to do is I want you to cover it up, and I want you to look at that number now. Doesn't that look like a fraction, an improper fraction? Big number on top, small number on the bottom. Okay, so then you ought to be able to go into a mixed number pretty easily in your head. 6 goes into 20. How many times? 3 times, because 3 times 6 is 18. All right, and then that would leave us with how many? 6 times 3 is 18. Leave us with 2. So that'd be a 2 over 6. But can't we reduce 2 over 6 to 1/3? Reduce fractions to lowest terms. So x equals 3 and 1/3. All right, turns out that it's a repeating decimal. If we do it like that and we turn it into a mixed number, that means everybody in the room is going to have the exact same answer. All right, if I just would have taken a calculator and went 20 divided by 6, some of you might have wrote 3.333. Somebody else might have wrote 3.3. Someone else might have wrote 3.33. Okay, so you all would have rounded to a different spot. So if we turned into that mixed number, we all have the same answer. Okay, so if you've not seen that, which I'm guessing you haven't, that's new. Okay, we'll keep that one there. That's what I want you to do those. All right, now, ones that look like, maybe say, a -2 is equal to an x minus 5 over, excuse me again, let's put a 4 down there at the bottom. All right, now this one has got division in it, but it's a much longer division bar. There's a whole entire binomial up there on top, x minus 5, and then a 4 on the bottom. Every one of these, I said add or subtract first, then multiply. Add or subtract first, and then multiply or divide. Distribute, but then add or subtract, and then divide. This is the exception to the rule. All right, because that division bar is under all of that, then we have to multiply first. Excuse me. Divided by 4. It's horizontal bar. So this is showing me dividing by 4. What's the opposite of dividing by 4? Multiplying by 4. So I can multiply by 4. Again, I'm going to kind of write that up to the top so I remember it's in my numerator. And then I'm going to multiply this side over here by 4, and I'm almost out of room right there. The 4's on the right-hand side go away. When I multiply on the left, 4 times -2 is Negative 8 equals, now the 4 is crossed out, but I still have the x minus 5. Now that's a one-step equation with adding or subtracting. What am I going to add to both sides? The 5. Why? Because I find the middle, I find the x, I find the number that's on the same side as the x. That's how I choose what I'm going to add to both sides. So I add 5 and I add 5. Those two cross out. What's a negative 8 plus 5? Negative 3? Ooh, not negative 13. How about negative 3?